friends, you are watching ERUDIRE Plus, the professional CAD/CAM solution provider. This channel provides basics of finite element analysis and computer-aided mechanical engineering design and analysis using CAD-related software. Let's get started.
Hello friends, today I'll show CFD flow analysis through a duct using SolidWorks Flow Simulation. This is the model with different cross-sectional areas at the entry and exit levels. We are having different cross-sectional areas. So from here we'll pass air particles at a specific rate and we have to find out the discharge at different exit points. At the same time we'll see the pressure, velocity, temperature distribution at different surfaces, and throughout the passage also we'll see, right? We'll see the flow trajectories and also the pressure, velocity, temperature distribution throughout this passage, and by the same time we'll see some surface goals at the exit point, right? This is the model. The total length of this model is equal to 3000 millimeter. From here to here is 1300 millimeter, and from here to here this is 2300 millimeter. Okay, and the cross sectional areas are different. At the entry and exit level, this area is equal to 200 by 300 millimeter and a thickness of 2 millimeter, and at this location the cross sectional area is equal to 200 by 200 millimeter and the thickness is also 2 millimeter. Here also 200 by 200 and thickness 2 millimeter, right? We start from modeling itself, right? So we're starting from new part, and let's take the front plane normal to. For this type of drawing, it's always better to start with 3D sketches. We start with 3D sketch and line. Start with the line at any point with any dimension. Then next to that we can provide smart dimension to this one, as this one will be 3000 millimeter. And this height will be 800 millimeter. Done. Next one, here we have to provide some kind of fillet. So select that location and fillet. It will be 452 millimeter. Done. Grain check. So first part is complete. Grain check and exit from the sketch. Now again we have to do another part of this one, so we'll start with again 3D sketch, line, make any straight line and continue this one up to the starting point. Then at this point we have to provide some kind of fillet and dimension to be also provided. Let's provide smart dimension to this one. This one will be 800 millimeter and length will be 2300 millimeter. 2300 millimeter. Next to that we have to provide a fillet at the junction point. So select that location and fillet, and radius will be 402 millimeter. 402 millimeter radius. Grain check. Done. So again exit from the sketch. You have to start a new drawing again. So starting with 3D sketch again, line, let's provide smart dimension to this one as this one will be 800 millimeter, and length from the starting it will be 1300 millimeter. Done. Now finally we have to provide a fillet at the junction, so starting with fillet, and radius will be 402 millimeter. Done. Green check and exit from the sketch. Now we have provided different paths, and at the end of the paths we have to provide the cross-sectional areas, right? So starting with this point, let's select that point, and we can provide one plane on that. From reference geometry you can make a plane, and this plane and the point are in the same plane. We have to make this plane perpendicular to the line, so click the line. Now it is perpendicular to the line. Okay, we have made a plane. On that plane we have to provide that sketch, starting with sketch and rectangle. We can provide a rectangle of specific dimension. Let's provide smart dimension to this one, as this one will be 300 by 200 millimeter. 300, and this one will be 200. Done. So green check and exit from the sketch. Now we select the sketch and features, sweep boss base. Now I have to provide that path. It is done, right? Similarly for the other two paths also we have to provide the same thing. You can select the point, then reference geometry and the plane, and that will be normal to that point, so we have made it normal. Next one, on the plane we have to make one rectangle again. Just provide rectangle and provide smart dimension to this one as 200 by 200 millimeter square. Done. So green check and exit from the sketch. Again select the sketch and features, sweep boss base, then path to be followed. The drawing is ready. Green check. Done. Right, now the final one for this case, again select that point, then reference geometry, select a plane that will be normal to that line. Green check. On that plane we have to draw that rectangle again, so starting with the rectangle, provide smart dimension to this one as 200 by 200. Green check. Done. So exit from the sketch, select the sketch again and features, sweep boss base, select that path. Our drawing is ready. Green check. So we made the model solid, you have to make it now hollow, right? For making this hollow, we can make the use of shell command. So we'll select the shell and we have to select the surfaces. Select this surface and the entry surface also. We can select by control, and the shell thickness we want to make as 2 mm. green check, done. We made a shell, right? Now for better understanding, we can see the sectional view. You can see the sectional view, right? Okay, done. Now one thing is remaining here, that top plate already leads have been provided. We need not provide the lead separately, right? This is closed, so lead is not required at this point. You can see here at this point we have to provide the lead. Okay, you can check. Now you can see the complete model. So what we can see is, like, two leads have already been provided here and here, and entry and exit point at this location we have to provide some leads. And also we can do one thing, like this panes we can make it hidden. Right. So our model is ready. We can make the model transparent for better viewing of these flow particles. Appearance of this one with glass to make it visible. We select glass and clear glass we are providing. So the model is transparent right now, right? Now we have to provide two leads at the entry and exit point. This and this point we have already provided lead, right? So starting with flow simulation tools, create leads. We have to select the surfaces, select here and here also. So two leads we have already provided, right? We can check. Now to see whether our geometry is okay or not. For seeing the geometry, let's start with checking that. We have to have an internal analysis. I can check the geometry. It is showing status is successful, so geometry is okay. Now we can see whether solid volume is generated inside or not. You can check it. Show fluid volume. It is showing that status is successful, so we can start our flow simulation. Okay, so before starting we have to save this part. Let's save it with the name of part 1. We have said already. Now we have to create an environment for flow simulation, and that can be done using wizard. So starting with wizard, and default name of the project as project 1. We are selecting SI system or SI unit and considering temperature to be taken with degree centigrade, and pressure you want to be in bar. Next, it is an internal analysis and gravity will be required. You can see the direction of gravity. This is the model. So direction of gravity is, you can see here itself. So this is the model. So gravity is actually working in the y direction, right? So we have to put y equal to minus 9.81. Minus 9.81 meter per second square, and along z direction it will be 0. Next, we are considering the fluid as air particles. Next, a default wall thermal condition and roughness we are considering, and finally the atmospheric temperature we are considering as 20 degrees centigrade. So finish it. Now this is the computational domain. right? So we can make this domain as 2D or 3D also. We can start working with this model as a 2D simulation or 3D simulation. That much of difference is not available there. You can start with 2D or 3D, it will be almost similar thing. So we're starting with 3D simulation. Okay, so first of all we will hide this domain, and you have to provide boundary conditions. For better application of boundary conditions, it is always suggested to have a segmented view of this model. So we'll cut the model from front plane, and we can apply boundary conditions at specific locations, right? So boundary conditions, insert boundary condition, and we want to provide inlet volume flow rate as 0.25 meter cube per second. From the entry point here itself, and definitely thermodynamic temperature will be 20 degrees centigrade. So green check. First boundary condition is applied. Now again 3 more boundary conditions to be applied. That means at the exit points you have to apply atmospheric pressure at the exit points. So boundary conditions, insert boundary condition, we'll select that locations. Here we have to apply atmospheric pressure. Green check. It's done. Again at 2 more locations you have to apply the similar boundary conditions. So boundary conditions, insert boundary conditions, atmospheric pressure. We have to apply at this location. Select. Green check. It is done. And finally at this location also we have to apply boundary conditions. Boundary conditions, insert boundary conditions, atmospheric pressure, and we have to apply at this location. Green check. It is done, right? So all the boundary conditions have been applied properly. Now you can see the complete view of this model. This is the complete model, and remaining is we have to apply some goals. We have to have that surface goals at different exit points. So what we'll do is, as surface goals we'll select insert surface goals. We're going to find out volume flow rate at the different exit points. Select other, phase of shell number 1, phase 2, done. So one goal we have decided, that is volume flow rate at entry point 1. Can rename this one also, like renaming it volume flow rate at first exit. Done. Now again 2 more volume flow rates are required, so we have to provide some goals again. Goals, insert surface goals. We have to find out volume flow rate at second exit also. Select other, phase number 1, green check. We can rename this as volume flow rate at second exit. Done. Now the third one is remaining. So another surface goal we want to have. Goals, insert surface goals. We want to find out volume flow rate, that is average volume flow rate at the third exit. So select other, and phase lead number 2, Green check. We can rename this as volume flow rate at exit 3. So we have defined all the goals. Excluding these things, we can find out pressure, velocity, temperature at any location or throughout the passage also, right? Our model is ready. Now we can run this. So running it, let's run it. You can see that solver window has already started. Mesh generation is going on and preparation for calculation is going on. You can see all the results from the solver window itself. From here, let's see the results. We want to find out volume flow rate at the 3 different exit points, so we can see all these things. You can see the results at first exit, second and third, all these cases you can see the volume flow rate. Excluding this, you can see some other things like pressure, velocity, etc. From here, you want to see pressure, velocity, etc. Settings, velocity, and we can define this one at 400 by 300. Let's see velocity distribution. You can see here. You can make the drawing little bit bigger one. Let's make it bigger. Image attribution, we can make it 640 by 480. This is actually velocity distribution. You can see at the beginning velocity is very high in the range of 4.73 meter per second, and as it is approaching towards the exit, its value is decreasing, right? Similarly, we can find out pressure and temperature also. Let's see pressure. So from settings we can define pressure. Okay, so pressure is not having that much of a difference. It is almost similar, starting with 1 bar, and at the exit also it is same, but here at this point it is little bit higher. Okay, I can see something else like temperature also. We can check it. This is pressure. We can see temperature also. Now the solver is finished. We can see the results. You can see your results. First of all, we'll see the results in the form of cut plots. Insert cut plots, and we want to see in the form of velocity from front plane. Grid check. So this is velocity distribution along the profile. It's better to see from the front plane itself. This is velocity distribution. You can see at the entry velocity is very high. It is in the range of 4.69 meter per second, and as it is approaching towards the exit, its velocity is decreasing, right? Now we'll see the pressure distribution. Now we'll see the pressure distribution through its passes. Pressure is also, it's not changing that much. Now we'll see the temperature distribution also, temperature of fluid throughout this passage. You can see at the beginning temperature is very less. It is in the blue zone, that is 20 degrees centigrade, and as it is approaching towards the exit of different ends, its temperature is increasing a little bit. At first entry, temperature is high, 20.01 degrees centigrade. The second point also, it is 20.01 degrees centigrade, and at the third exit it is in the green zone, that means little higher compared to the starting point, very little. Okay, these are the things. Now we can do one thing. We can see this cut plots in the form of animation. So we start an animation. Cut plot 1, let's play it. It is showing temperature distribution in the form of an animation. You can see these things in the form of velocity also. Let's provide velocity. Now it is showing velocity distribution throughout this profile. Now let's clear and hide this part. We can generate some surface plots also. We can guess what it will be at the surface. Velocity will be 0, right? We're going to see using all the faces. Green check. You can see the velocity at the boundary it is 0, right? And at the middle point the velocity is high. You can see pressure, temperature, etc. all these things throughout these passes or throughout this whole body. You can see now pressure. You can see pressure is also different at different phases. At the top level pressure is less and down level pressure is very high, right? These are the things you can see from these cut plots. Now very important part we can see is like flow trajectory. That is how the air particles will be passing from entry to exit. For seeing this one, first of all we have to make this cut plots to be hidden. So surface plots, clear and hide. Now want to provide flow trajectories. So insert flow trajectory, and the numbers instead of 20 we want to make it more. Maybe you want to make this one as 100 numbers, and we want to see these things in the form of arrows only. And we want to see velocity. Let's select that different locations from where we want to see this velocity, pressure, temperature, etc. So select other, leave number 1. Again we have to select some other locations also. Select other, selected, and the third one. Select other. So green check, we have selected 3 different faces. You can see the passage of air particles throughout this profile. Better to see these things in the form of an animation. So flow trajectories, clear and hide, and let's play this one. Flow trajectories, play. You can see here in this case some kind of like difficulty is there. You can see that some kind of backflow is occurring here. That means that design we have to recheck and modify this design. We are seeing the pressure. You can see velocity, pressure, temperature, etc. Let's see velocity. You can see the passage of these air particles from entry to exit level. At the entry point you can see the velocity is very high in the range of 4.695 meter per second, and at different entries with the color of these aero particles we can identify the velocity ranges. We can see some kind of problem here. It says some kind of backflow is occurring at the first entry. Water particles are coming back from here. This is okay. So at this location you can feel some kind of backflow is occurring. So this type of design we have to modify, right? Now the final thing we have to see our full plots, right? So we can make this flow trajectory hidden, clear and hide. Now next one we have to see our results, right? So goal plots, we want to select all the goals. That means we want to find out volume flow rate at different exit points. Show the results. It is showing the results in the form of data. You can find out at the first knob exit, volume flow rate is 0.0294 meter cube per second. Second one is 0.0485 and third one is 0.172 meter cube per second. These are the different volume flow rate at different exit points. Now all these things you can see in the form of graph also from history. These are the volume flow rates at different exit points. For better analysis, we can transfer this data to Excel and go for detailed analysis, right? Okay. Now another thing can be done with this data. We can generate a report. So we'll show it. Generate a report. And for generation of this report, some options are available. From here, we'll see from the templates itself. We're having different templates. Let's take the first one. Open it. And you can see that a report is being generated in MS Word file. This report has already been generated. You can see the all data, all the boundary conditions and the results also available. But we cannot see the sketches or these graphs. We can provide these things here itself. For providing these sketches, what you have to do is we can take these pictures from here itself, and it will be from current image. Add to report. It can be added at entry point or it can be added at the current position. So we are providing this sketch at the end of the document. So add to report. This drawing is already added to the report. We'll see that. This drawing is already added, right? Next one will show some cut plots of pressure and temperature. So what we'll do is we'll go to the results and we'll go to results and see cut plots. Cut plot 1, show. This is actually velocity distribution. We want to see from front plane. And that one we want to provide in the report, right? So add to report. You can see the report. This is already added with the report, right? This is velocity. Again, if you want to see pressure, temperature, etc., that can be generated also. Next one we're going to see pressure. Okay, pressure has come. Now that to be added with the report. Let's see the report. Pressure is added, right? Similarly, all the things like what we have generated in our analysis, that can be obtained in our report, right? Now let's close it. So this is all about our today's CFD analysis of flow through a duct using SolidWorks Flow Simulation. What we have done here in this case, we have allowed to flow some kind of air particles at a specific rate from one entry, and we have gathered some information about its velocity, pressure, temperature, etc., and also we have found out their volume flow rate at different exit points. Okay, so this is all about our today's analysis. If you like this one, please subscribe and share, and if you have any kind of doubts, please write to me. Thank you so much for watching this video. Thank you again. Bye.